Let's try one more together before you try one on your own. So let's start off. We want to know our velocity. Taking the derivative of position, derivative of 24 is 0, derivative of 6t is just 6, and derivative of negative t cubed would be negative 3t squared. And then for our acceleration, we're taking the derivative of the velocity, so acceleration is just going to be negative 6t. Now, we want to go ahead and draw a little diagram showing the motion. So remember, we're going to go ahead and use when we have our endpoints, as well as when our velocity is 0, because that's when it can change direction. So we're going to take our velocity and set it equal to 0. We can subtract 6 and divide both sides by negative 3. We get t squared equals 2. So if we take the square root of both sides, t equals positive or negative square root of 2. So to find the points that we're going to put on our little diagram, we're going to figure out what the position is at negative 2, negative square root of 2, positive square root of 2, and 3. Now you need to make sure when you find these values when the velocity is 0 that it falls within this interval. So if we had something like negative 5, we wouldn't bother using it because it's not in between those endpoints. Now if we go ahead and plug these in, put negative 2 into the original function, we should get 20 out. Negative square root of 2, we get approximately 18.34. Positive square root of 2 into the original function, we get about 29.66. And we put 3 into the original function, we get 15 out. Alright, so for our number line here, we're kind of ranging from about 15 to about 30. So I'm going to start over here. Got 15, I'm going to go up by 5s. And go ahead and plot these points on our graph. So start off at 20 for our position. Then we go to the left to 18.34. Then we go to the right to 29.96. And then we go back to the left to 15. So we can connect those. Going to the left, then to the right, and then back to the left. We want to label those with the time. So this is at t equals negative 2, t equals negative square root of 2, t equals positive square root of 2, and t equals 3. The last part we want to do is go ahead and figure out when it's speeding up. Let's start off with a number line, and what we're going to put on here is when our velocity was 0, which we've already figured out. We put velocity on top. That's at negative square root of 2 and positive square root of 2. So we have to plug in values either side to figure out when the velocity was positive or negative. So if we put in something smaller like negative 2, we put negative 2 into the velocity, 6 minus 3 times negative 2 squared. We're going to get 6 minus 12, so that's going to be a negative value. Then if we put 0 in, that falls in between these two. Put 0 in, we're just going to get a positive 6 for our velocity. So all of these are going to be positive. And if we put a positive 2 into our velocity, 6 minus 3 times 2 squared, we're going to get a negative value again. So we can tell when our velocity is positive and negative. Now, on the bottom, we have to do this for acceleration. So we didn't figure out when that's equal to 0 yet, but if we look at our equation, it's pretty easy. If we want to know when that's equal to 0, our only answer is when t is 0. So we just have to look to the left of 0 and to the right of 0 for our acceleration to figure out when it's positive and negative. If we put a negative value in for t, our acceleration is negative 6 times, let's try negative 1. That's going to give us a positive acceleration. If we put a positive number in for t, like 1, we get a negative acceleration. So for this, we're trying to find out when it's speeding up. That happens when they're both the same. Velocity and acceleration are either both positive or both negative. So it's speeding up from negative square root of 2 to 0, and from square root of 2 to infinity. Or in this case, sorry, square root of 2 to 3, because we have our endpoints here.